Hi guys, welcome to video 8.4. This is going to be all about acid-base indicators and how to tell which indicator to use during a titration. So indicators are actually weak acids, and what happens is they have a different color between the weak acid and the conjugate base. So based on the predominant form, the color of the indicator will be different. Now each indicator, so whether it's phenolphthalein, methyl blue, methyl red, each indicator has its own pH range over which it changes color. And the indicator is really dependent on the pH, specifically at the equivalence point. And an indicator can be used to actually find the equivalence point as long as it changes color in the volume change where the pH is changing for the specific titration. So essentially you need to make sure that the indicator changes color where you expect the equivalence point to be in a titration. So with acid-base indicators, the equivalence point can be determined by measuring pH, and we've done that already. But it can also be used by looking at an acid-base indicator, and an acid-base indicator marks the end point. So there is a distinct difference between the equivalence point and the end point. Equivalence point is when moles of acid equal moles of base. End point is when the indicator changes color if you're using an indicator. Now typically we use pH probes, but you could use an indicator that tells you the equivalence point, or excuse me, the end point. So although the equivalence point, which is defined by stoichiometry, although equivalence point isn't necessarily the same as the end point, usually the difference is negligible. So usually you can assume that the equivalence point will be the same as the end point. And like I said before, acid-base indicators are weak acids, so they're very complex molecules. We're not going to worry about what the formula for the indicator is itself, but we just need to know that it's a weak acid, and we're going to represent it by HIN. So IN would be like the conjugate base, HIN would be the weak acid. So then they exhibit one color when you're focusing on the weak acid, and then they exhibit a different color when you're looking at the conjugate base. Now the indicator choice can be critical because if you choose the wrong indicator, so notice phenolphthalein changes between a pH of 8 and 10. Well, if your equivalence point is somewhere between 5 and 7, well then phenolphthalein is not going to be of any use. So you need to make sure that the indicator that you choose changes color when you need it to. So methyl red might be a better choice if we need the equivalence point to be between 4 and 6. Phenolphthalein might be better if we expect the pH at the equivalence point to be higher. So this just shows some different indicators that you might use and the differences in color. So bromothymol blue in acid is yellow, but if it's in a basic solution, it turns blue. Methyl orange is a reddish pink in an acid, but it turns yellow-orange in base. So notice the differences in colors. And then phenolphthalein has these different colors at different pHs, so it's clear if it's in acid, and it turns pink when it gets between a pH of 8 and 10. So notice at a pH of 8 it's still somewhat pink, but at a pH of 9 it's significantly darker. Now this slide is just going to show you the derivation of why indicators are useful and why we know what we know about pH with indicators. So if we consider this indicator, this HIN, this is a weak acid, I gave you the Ka. It's red in an acid, it's blue in a base. Now we could rearrange this entire Ka expression to look at the ratio of IN minus to HIN, and then we can add a few drops to an acidic solution. Now, we know this is red, we know the conjugate base is blue. Now what this ratio right here shows, and again this is just looking at the derivation, this shows that the predominant form is HIN because it's 1 to 10 million. So the predominant form is HIN. But as we start to add more OH minus, we start to add more base, this H plus is being used up to neutralize. And Le Chatelier's principle says that this is now going to shift to the right, and we're going to be using up this HIN, we're going to be making more of this IN minus, which means at some point in the titration, it will go from a red color to a blue color. And that is why indicators change. Now it can also be shown, and remember we do not use the Henderson-Hasselbalch equation, instead we use the only equation that we have to memorize, So we can show through experimentation and through math, we're not going to worry about it though, that the color transition is given by pKa is plus or minus 1. So what this means is if we want the color to change, then we need to look at the pKa. So bromothiamyl blue has a Ka of 1 times 10 to the negative 7, so you take the negative log of that, pKa is equal to 7. Now what this is saying is that bromothiamyl blue would be useful in a pH range of 7 plus or minus 1, right? pKa plus or minus 1 gives us the pH range. So bromothiamyl blue would be useful from a pH of 6 to 8. And so what we can actually do is we can actually select the indicator by looking at the pKa. So you want to select an acid-base indicator whose pKa value is as close to the pH as possible to the pH that you want to detect. So usually it's the pH at the equivalence point. So if you're asked to pick an indicator, you want to compare the pH at the equivalence point to the pKa of the specific indicator. And then this simply shows the different indicators and where they change color, and you've seen this before, but this shows all of the different indicators that you could use. And then this is the pH curve. Notice that neither of these indicators would be useful at this equivalence point. Phenolphthalein changes too high, methyl red changes at too low, so we would have to pick something that would be right in the middle. And so if we want the equivalence point to be right at 7, bromothiamyl blue, which has a pKa of 7, would be useful. And then this shows even more indicators and where they change color. So when you're looking at the different potential indicators, this actually shows you all the different indicators that we could use.